What makes a software good? When they say a software is good, what actually makes it good? Today, we expect that when a software is built, it should be fast, secure, reliable, and easy to use. But software quality wasn't always viewed this way. In the early days of computing, if a program simply works, that was considered good enough. Over the decades, however, software quality thinking evolved. It changed from merely fixing bugs to building quality into every stage of development. In this video, we'll explore the fascinating history of software quality thinking and see how it transformed from a simple concern into one of the foundations of modern software engineering. Let's look at the early era of software quality thinking. In the early days of computing, software quality wasn't a formal concept. Programs were small and written primarily for scientific and military purposes, and because of that, the number of users was limited, and then also the development teams were small. But there was one main question that the developers always asked, which was that does a program produce the correct answer? Does it compute the right answer? And if the answer was correct, the software was considered successful. There was no formal testing methodology, no quality standards, and also very little documentation. Most errors were discovered only after they occurred, and debugging was done manually. So, when the system has been released and an error occurs, that is when they can find the error. Then they can now debug it manually. Quality at this stage meant correctness and nothing more. So if the system runs, then it is good enough for them, and then nothing is deemed as wrong. But as computers became more powerful and software systems grew larger, new problems begin to emerge, and these problems will lead to what is called or termed and known as the software crisis. By the 1960s, software projects were becoming increasingly complex. Many projects suffered from delays, exceeded budgets, and then failed to meet expectations. Because of this, organizations realized that writing software was becoming more difficult than managing hardware. This problem became known as the software crisis. In 1968, the NATO conference introduced the term software engineering, and this idea was revolutionary. Why do we say that? This idea brought about software development, and it was treated as an engineering discipline with structured methods, standards, and processes. People began to realize that quality had to be planned and not left to chance. As software engineering matured, attention shifted to one major question. What was that question? How do we prevent defective softwares from reaching users? The answer was what we call testing. That was when testing came about. Now, during the 1970s and then the 1980s, software testing became a major focus. Developers introduced concepts such as unit testing, integration testing, system testing, and also verification and then validation. Companies also adopted inspections and code reviews to identify problems before release. Quality became strongly associated with finding and then fixing defects. The philosophy was straightforward. The more bugs we detect before release, the better the software. Although testing significantly improved reliability, experts eventually realized that testing alone wasn't enough. People started asking an important question again. Instead of detecting problems, why not prevent them in the first place? We all know the word prevention is better than cure. So why don't we prevent the defects or the problems rather than trying to fix them later on? So the idea changed software quality forever. During the 1980s and then the 1990s, organizations shifted their attention from software products to the development process itself. They recognized that poor processes often produce poor software. So this period saw the rise of total quality management, ISO 9000 standards, capability maturity model, and then the others. Now, the Software Engineering Institute introduced the capability maturity model to measure how an organization's software process were. The focus shifted from detection to defect prevention. The philosophy became that a good process produces a good software. As software systems became even more sophisticated, engineers wanted ways to measure the quality objectively. So what did they do? This gave birth to the era of software metric and engineering maturity. In the 1990s, software quality became increasingly measurable. Developers introduced metrics such as defect density, code complexity, reliability measures, maintainability indices. Object-oriented programming also became widespread, making systems more modular and easier to maintain. Automated testing tools also began gaining popularity. Software quality was no longer viewed as a vague concept. It became something that could be measured, analyzed, and continuously improved. Then came one of the biggest transitions in software history. Agile development changed everything. In 2001, the Agile Manifesto introduced a new philosophy for software development. Instead of long development cycles and late testing, teams embrace iterative development, customer feedback, continuous integration, test-driven development. Quality was no longer a final step. It became part of the entire development process. Developers adopted a principle: build quality in from the beginning. So the key idea was that quality is built in, not that it was added later. But software development continued to evolve. Soon, another movement emerged that would bring developers and operation teams together. This movement became known as the DevOps. Today, software quality extends far beyond by free code. Modern organizations use DevOps and DevSecOps practices to ensure quality throughout the software lifecycle. Automation plays a major role through continuous integration, continuous delivery, automated testing, real-time monitoring, and then security testing. Now, software quality now includes attributes such as reliability, scalability, security, performance, user experience, maintainability. Quality is no longer the responsibility of testers alone. It has become everyone's responsibility. The history of software quality thinking tells an interesting story. We move from asking, does the program work? So far as it is running, isn't it correct? We move from such a question then to, can we prevent defects through better processes? And finally, to the question, can quality be built into every stage of development? Today, software quality is not a single activity. It is a continuous process involving developers, testers, and operation teams. As software becomes increasingly integrated into our daily lives, quality will remain one of the most important factors determining whether a system succeeds or fails. Thank you for watching, and if you enjoyed this video, don't forget to like, subscribe, and then share. But also remember that for a good quality system, the software doesn't happen. A good quality software doesn't happen by accident, but instead it is rather engineered.